Hello everyone. In this tutorial, I want to talk to you about Kirchhoff's voltage law. I will start with a simple example. According to Kirchhoff's voltage law, the sum of the voltage is zero if I move from a point in the circuit and return to the same point. If I move from point A and return to the same point, then the sum of the voltages will be zero. Let us assume we have two resistors of 3 ohms and 7 ohms. And that is, I assume that the current direction is within the clockwise. I move from point N and go back to point N, and the sum of the voltages according to Kirchhoff's law should be zero. For the first step, I need to mark the direction of the current in each resistor. The direction of the current in each resistor will be the same as the current direction. So it will be more convenient for us to express the voltages. I will write here plus and minus here, because the voltage the current moves from the higher voltage, which is the plus, to the lower voltage, which is the minus. The same here. The direction of the voltage is the same as the direction of the current. And like the end of the arrow is where the minus the voltage, the same here. This is the minus and the plus. The end of the arrow, I will show it when at the minus of the voltage. I start with point N, return to point N, the clockwise. Then UR1 plus UR2. UR1, the arrow is with our direction of UR1 and UR2. This is UR1. This is UR2. And the direction of the voltage of V1 is against our direction. And because of that, I write minus V1, and the sum is zero after I return to point A. The voltage of R1 is IT multiplied by R1, and the voltage of R2 is IT multiplied by R2, minus V1 equals 0. IT by 3 plus IT by 7 minus 10 equals 0. 3 IT plus 7 IT equal 10. I move the minus to the other side of the equation. 3 plus 7, 10 IT equals 10. Then IT equals 1 ampere. When I multiplied IT by R1 to get the voltage of R1, then IT multiplied by R1 is 1 multiplied by 3 volts, and the same with R2. This is a simple example how we can use Kirchhoff's voltage law to solve a simple circuit. Now I will show you a little more complex circuit. In each loop, I will decide which is the direction of the current. A more easy way is to decide that the current direction in each loop will be with the clockwise. It doesn't have to be in the clockwise, of course. It can be in the opposite. We can choose the direction we want, but for more convenient solution, we should decide that the direction of the current in each loop will be the same. I will call this current as I1 and this I2. Please notice that the I1 is the current only of the external branch. I mean only by R1 and V1, not by R2. This is I1 is not the current flowing through R2. The same with I2. I2 is the current through R3 and V2, not by R2. Soon I will explain to you why I took the current in the same direction in each loop. I will mark this point as A and mark this point as B. Now I'm working on the left loop. I'm start from A to A in the clock direction, clockwise. Okay, I move from A and return to A. I will mark the direction of the current, of the voltage, sorry, on R1. This is R1 plus minus, the same as the current direction, the same here, plus minus. At the position of the minus, I will mark the end of the arrow. This is the minus plus, the same here. Direction of the current I2, direction of the voltage. When the minus at the end of the arrow, the same here, plus minus, the direction of the voltage of R2. Note that this is opposite. The direction of I2 is the opposite of the direction of the other side. This is because when I want to express the voltage of R2, I will use it with I2 when I am in the right loop, I2 minus an I1. This will be always in minus when the two current direction are in the same, when the two when the current direction in each loop is the same. Okay, we start with the left loop. UR1 plus UR2 minus V1 equals 0. I1 by R1 I1 is the current through R1, plus when I'm the left loop, I1 is always positive, the current in my loop is always positive, and the current in the other loop will be zero. It will be, will be negative. This is why I wrote I1 minus I2. This is multiplied by R2. Now I see the minus of V1 and I write minus V1 equals 0. When I write the numbers, I1 is 10 plus I1 minus I2 by 20 minus V1, which is 10, equals 0. I have here 10 I1 plus 20 I1 minus 20 I2. I open the brackets. Minus 10 equals 0. 30 I1 minus 20 I2 equals 10. I have first equation, right loop. Starts from B, to B in clock direction, clockwise. UR3, which is positive because it's in the current direction, plus V2. V2 is positive because the voltage direction is the same as the current direction, because I always mark the position of the minus as the end of the arrow. Continue to R2, and this we wrote I2 minus I1 by R2, because the current in our loop, now I am in the right loop, then I2 is positive and I1 is negative. I2 minus I1 by R2. This is equal to 0 because we complete the circuit and return to the circle, and return to point B. Now UR3, which is the voltage of R3, is U2 multiply I2 divided by I2 multiplied by R3 plus V2, which is 20, plus I2 minus I1 multiplied by 20 equals 0. 30 I2 plus 20 plus I2 plus 20 I2 minus 20 I1 equals 0. I will arrange the I1 below I1 and I2 below I2. I will start with I1 minus 20 I1 because I1 is in the upper equation I found is first. Then I write here also I1 as first. I will continue to I2 plus 50 I2 equals minus 20. When I solve the equation, after I write them one below the other, the answers, we'll calculate it now. 30 minus 20. I'm calculating it it using the computer. The first answer is 0.0909 amperes, and the second is minus 0.363 amperes. Now I will mark the direction of the current in each loop. I1 is, because I1 is positive, then the direction of the current I assume first of I1 is true. That's why I1 is the same direction I assumed. And I2 is in the opposite direction I assumed. That is why I2 is going to left. 0.363 amperes. Now we can see that to B enters two current, and according to Kirchhoff's current laws, the sum of the current entering the intersection is equal to the current getting out of the intersection. I mean that if this is the current through R2, then I1 plus I2 equals to IR2. This is the current going inside B. This is the current going outside B. It means that 0.0900 plus 0.363 equals IR2, which is IR2 equal 0.453 amperes. Now IR2 is 0.453 amperes.